Alright, hey guys, my name's Reese, and I'm gonna do the extra credit for exam 5, number 1. And so let's get started. The first one asks to derive the formula for the Laplace of delta of t minus a. She added that you do not need to derive the formula for delta t minus a. So we'll just assume that delta, here, let's write it up here. Delta of t minus a is equal to our function d sub epsilon t minus a, and that's going to be equal to give me 1 second. Sorry. U sub a sub t minus u sub a plus epsilon t all over epsilon. And so the graph, just to give you a more intuitive sense, should look something like this. Here, well, I guess I'll make it in red. So it's 0 until a, and then it stops at a plus epsilon, and then it becomes 0 again. And there's just one. This right here is just 1 over epsilon. So this should be 1. If you look in the notes, I'm not gonna derive that part. Actually, is that what she's implying that I have to derive? Derive. The formula. Okay, yeah, I'm just gonna assume that because it says you do not need to derive the formula. That we'll just know that delta sub t minus a, the interval here, oh my gosh, I'm gonna write it right there, from negative infinity to infinity dt is going to equal 1. I think we're just making this assumption. I think that's what she means by you do not need to derive the formula. If not, well, oops, I guess. So, okay, so we're going to start with the Laplace delta t minus a. So this would be equivalent to the limit as epsilon approaches 0 from the positive side, because as you can see in the graph, it's only in the positive direction. And then we're going to substitute this guy here with our more defined function, d sub epsilon of t minus a. And then we're going to rewrite that using this guy. Or actually, we'll just do this first. So the limit of epsilon approaches 0 positive side. And then we're just going to use the definition of a Laplace transform. So it's just going to be from 0 to infinity, from e to the negative st, times our function, d sub epsilon of t minus a dt. And now we could substitute this for this guy. So the limit as epsilon approaches 0 from the positive side, 0 to infinity, e to the negative s of t, times u sub a sub t minus u sub a plus epsilon sub t all over epsilon, that's a 3, epsilon dt. And then, you know from the graph that from the bound 0 to infinity, it's 0 everywhere else besides a and a plus epsilon. That's when it like quote unquote activates. So you know everywhere else is going to be 0. And then you know that the height, oh, that is not epsilon. You know that the height's going to be 1 over epsilon, so we could just substitute that for this guy. So we're going to rewrite that here. Limit epsilon approaches 0 from the positive side. And then it's going to start from a, and then it's going to go to a plus epsilon, because that's the only, from 0 to infinity, those are the only bounds that really matter. It's going to be e to the negative s of t, and 1 over epsilon of dt. Is this a 3 again? Oh my god. Oops. Keep on doing that. And so you know that 1 over epsilon is going to be a constant because you're integrating with respect to t. So limit as epsilon approaches 0 from the positive side, 1 over epsilon, and then you can just this is a really easy integration, but I guess I'll use up it just to show you. So u equals negative s of t, du equals negative s dt, and then so dt equals du all over negative s. So you're just going to substitute that in. Shoot, I guess I'll just do it like this. You're a plus epsilon. And so e to the u, and then negative 1 over s du. And then the integral of e to the u is just e to the u, so this is going to be, oh, and then you could actually factor out 1 over negative s, because that's also just a constant. So we're just going to write it as a limit e, not e, epsilon approaches 0 on the positive side, 1 over epsilon multiplied by negative over 1 over s times e to the negative s of t, and then that's going to be, just write it like that, and then a plus epsilon, and then you're just going to do this, finish the integration. Like I said, you could just factor out 1 over s, then it'll be e to the negative s of a plus epsilon minus e to the negative s of a. And from here, we can, here we'll just multiply it all out just so it looks a little bit better. Actually, yeah, actually, there we go. E to the s of epsilon minus e to the s of a. Cool, and then you could factor out this term, e to the negative s of a. And we're also going to factor out negative, or just 1 over s. So e to the negative s of a over s times the limit as epsilon approaches 0 from the positive side. Then we're going to leave the negative. So then it becomes this term becomes 1, and then you're just going to leave this term there if you factor out this guy. So it's going to be 1 minus e to the negative s epsilon all over epsilon. And then from here, we're going to use L'Hopital's rule right here. I'm not going to spell it. I'm not going to embarrass myself. So you just take the derivative of the top and the derivative of the bottom. So the derivative of 1 minus e to the negative s is just going to be e to the, s e to the negative s epsilon all over 1, I think, right? Oh, I should move this. I should write everything else first. Oops. Alright, so then you can see that these two guys are going to cancel, and then with the limit, you can see that the top is just going to go to 1, because the limit of e to the negative, we'll say x, the graph looks like this, and as you approach 0 from positive, no. Yeah, it's gonna look like this, and that's gonna approach 0. Or, shoot. Yeah, wait, that would approach 0 then. From 0 to the positive side. Give me 1 second. Oh shoot. Okay, never mind. So this would just be e to the 0 basically. My bad. And then this would just equal 1. Okay, cool. Got a little confused. I was like, what? And then this should just equal e to the negative s of a. And so the Laplace of delta t minus a is going to be equal to e to the negative as. Cool, so that was part A, and then we're going to do part B. Okay, so honestly, I think part B is kind of easier, to be honest, at least for me, because I understand what we're doing a lot more in the conceptual part, I guess. Part A. So let's just rewrite. We'll just take the Laplace of both sides. So y double prime minus 4 y prime plus 13y equals the Laplace of delta t minus pi over 4. And then just keep in mind that the initial values there, and then we're just gonna separate each of these terms. So you know from the top here that it's just gonna be that we derived in part A. It's just gonna be e to the negative pi over 4s. Cool. And so this guy's just a formula, and then this guy is also just a formula in chapter 10. I'm not too sure exactly which one it is, but it's just a formula, so you just kind of memorize it. So it's s squared Laplace of y minus s, y initial minus y prime initial, and then minus 4 Laplace of y, s Laplace of y. Plus, because it's a negative, plus 4 y initial, and then plus 13 Laplace of y is equal to e to the negative pi over 4s. So then we're just going to combine like terms. So this should be s squared minus 4s plus 13. Laplace, oh my gosh, Laplace of y. And then just keep in mind the initials. So 3s, this is going to turn to 0 because it's equal to 0. And then plus 4, 2 times 3. And that's just 12. So we're just going to write that as 12. Cool, so then you're just going to add 3 and minus 12. And then this on the left does not factor. So plus 3s minus 12. And then you're going to, shoot, I guess I should show it. Well, it's okay. And then you divide this term by both sides. And that's going to turn to pos of y. And then to make this a little bit easier, I'm going to make it e to the negative pi over 4s times 1 over s squared minus 4s plus 13 plus, and then we're going to combine these two terms on top. 3s minus 12 over s squared minus 4s plus 13. Cool. And then for this guy, for both of them, you're going to complete the square. So you're going to do negative b all over 2a equals negative. Oh, wait, no, it doesn't mean negative. It's negative because it's negative 4. 4 all over 2, and that's just going to be negative 2. But you square that. Wait, this is squared. Oh my gosh. Alright, so then this is just going to be s squared minus 4s plus 4, and then minus 4, so that it's technically the same, and plus 13. I guess this will be in red, I guess. And then if you factor, it should be s squared minus 2, or not s squared, what am I doing? S minus 2 squared, and then this becomes 9 plus 9. So you're just going to substitute that in for both of these on the bottom. Okay, so you know that this one looks really close to the sine function. It would be sine, if the constant up here was 3, so we're just gonna multiply. I'm gonna get more space here. We're gonna multiply the top and the bottom by 3, so that you're just multiplying by 1. Here, actually, 3, and then have 1 over 3 right there, just so it looks a little bit better. And so for this side, you can make it cosine if you just do 3 times s minus 2, and then it's gonna be plus 6 minus 12. Is that what I had before? I didn't write it. Oh, yeah. Okay, because if you distribute this, well, 3 times negative 2 is negative 6, and if you add 6, it's just gonna be 3s minus 12. So you're all set up there. And so you know that because of this, once you do the Laplace inverse, you're gonna have two shifting functions. So here, let's do the Laplace inverse of both sides. So then the left side just becomes y. This is gonna equal to, and then this guy is just gonna be use of pi over 4 of t. Cool. And then, like I said, this is going to be 1/3 on the outside. E to the 2t minus pi over 4 because of the two shifting functions. So the first one, e to the 2t, and then because of this guy right here, it'll be minus pi over 4. Then times sine of 3t minus pi over 4. Cool. And then for this one, we're going to separate it into two terms. So we're going to factor out the 3 on the first one. It's going to be s minus 2 all over s minus 2 squared plus 9. And then it's just going to be minus 6. Or I guess, yeah, we're just going to leave it at 6 for now. So s minus 2 squared plus 9. You know that this guy, you can just make it 3 times 2 all over s minus 2 squared plus 9. And then if you just factor out the 2 on the outside right there, this is just sine again. So yeah, I'm gonna erase everything. And then just 2, 3. Oops, I didn't. This is still Laplace inverse technically, because I didn't do that part. Okay, and we're just gonna deal with the right side that I didn't do yet. So this is just gonna write as 3 e to the 2t. Notice that it's just 2t because it doesn't have use of pi over 4. And then it's going to be cosine of 3t. This one's going to be minus 2 e to the 2t sine of 3t. Awesome. And then I'm just going to copy and paste the top. Alright, cool. And there's your answer right there for 2A, or 2B. And I hope that helped. I'm sorry if mine was very confusing, but thank you.